All right, students, today we're going to talk about Unit 6, Section 2, Rational Exponents. All right, recall that the radical symbol is used to indicate roots. The index, I think that's a new vocabulary word for you all, is the small number to the left of the radical symbol that tells which root to take. For example, this 3 is the index, okay? And it tells you what root to take. That would be the cubic root of whatever number we put inside that radical sign, all right? So, since 2 cubed is 2 times 2 times 2, which is 8, well, the inverse, or the converse of that, would be the cubic root of 8 would equal 2. All right? Now, on your calculators, if you're using my calculator, you're going to see your power button that looks like this, and above it, in blue, you're going to see your index x and your radical sign, okay? So what you're going to need to do is you're going to need to hit the second function button, and then this. So, for example, if we want to key this in right here on the calculator, you would key in 3. And if you're using my calculator, you'd hit the second function button, and then this, because that's going to bring up your symbol like that. And then you're going to key in 8 and hit equal, and you'll get 2. And what that did was, it took the cubic root of 8. All right. Okay, so I want to show you all how we're going to get this definition down here so you can try to understand it, okay? So let's say we take the square root of b, and then we square it, and then we have b to the k and square it. All right? Now, what we're trying to do is we're trying to solve for k here. All right? Let me back up. Moving ahead of myself. Let's say we have b, square root of b, and then we have b, k. And what we want to do is we want to solve for k here. Okay? So, what we can do first is to cancel out the radical sign. If we square this sign, that is the square root of b times the square root of b, which is b times b, which equals b. Okay? Just like we do when we solve equations. What we do to one side, we must do to the other. So let's square this side. So then on this side, we have b 2 times k. All right? Because I took k times 2. What this is it's bk twice. All right? So I have 2 b's and k. All right. What we want to do is we're trying to solve for k. So b is the same as b raised to the exponent of 1. So what we can do is we can cancel out these b's, our bases, and put 1 equals 2k. So what does k equal? K equals 1/2, right? So, guys, you don't need to be able to prove this, but I want you to understand how we get from here to here. So what I have is, if I have the square root of b, and I have b squared, excuse me, if if I have the square root of b, what does this equal? It equals b to the 1/2. Because we started out with the square root of b raised to b to the k, right? So k is 1/2. So, the reason why I'm trying to show you this is, what if we have the cubic root of b? What would b be raised to? 1/3. What if we have the 4th root of b? What would b be raised to? 1/4. Y'all see why I'm showing you this? What if we had this? What does that equal? What's our exponent? B to the 1/10. Okay? So that's how we come up with this definition here, what you're going to start practicing today. Square root of 3 is 3 raised to the 1/2. The cubic root of 5 is 5 raised to the 1/4. The 7th root of 2 is 2 to the 1/7. All right? So let's practice some of this. I do need to go over a helpful hint here, guys. So if b equals 0, if b equals 0 right here, let's do that. Let's substitute 0 in for b. All right? What is 0 raised to anything? 0. So anytime b is 0, your answer is 0. What if we have b equals 1? So 1 raised to, doesn't matter, guys. Doesn't matter what it is. What's it going to equal? 1. So there's some helpful hints there before we get started. All right, so let's look at number 1 here. If we have 343 raised to the 1/3, that is equivalent to the cubic root of 343. All right? So what number can you multiply by itself 3 times to get 343? So my answer here is 7. Make sure you know how to key that in on your calculator, okay? All right, what if we have 81 to the 1/4? That is the 4th root of 81. So what number can you multiply by itself 4 times to get 81? 3. All right, so let's apply this now. Okay, so we need to simplify this first one here. So that's the 5th root of 32, which is 2. And this is the square root of 9, which is 3. So my answer here is 5. Let's try another one of those. Okay, so this is the square root of 121, which is 11. This is the 4th root of 256, which is 4. So my answer is 15. All right, what if we have something like this? Now, we know that b to the 1/3 is the cubic root of b. What do y'all see different here? You see that we have 2/3 instead of 1/3, okay? So what we can do is there's two things we can do here. We can change this to b to the 1/3 so that we can write it this way. However, we can't just drop that 2. So if we take b to the 1/3 and multiply it by 2, these are equivalent. Because b to the 1/3 times b to the 1/3 is b to the 2/3. Okay? So, if we have b to the 1/3 raised to the second power, what this is it's the cubic root of b squared. Okay? Now, another way you can look at that is we can take b to the 2/3 and we can change it to b squared to the 1/3. Okay? So what this would be, it would be the cubic root, that's how we're getting this, and then inside the radical sign would be b squared. And these are equivalent, and you'll see when we start applying some of it, okay? All right, and that's what I just explained right here to you. So let's go ahead and apply some of it. (81 to the 5/4). Okay, what I like to do is I like to change it to 1/4. So if I change that to 1/4, I'm going to raise that all to the power of 5, because 1 times 5 will give me this 5. Okay? So what I have here is I have the 4th root of 81 raised to the 5th power. Well, the 4th root of 81 is 3, and then I raise that to the 5th power. 3 to the 5th power is 243. Okay? Now I'm going to stop, make sure I have time. We've got about 3 or 4 more, so I'm going to do a second part here.